Hello, and welcome to a video on electronic configurations and using the mnemonic device that I'll refer to as the triangle method. Now, this is a mnemonic device. It's a memory aid for knowing how to fill in the electrons when we're doing electronic configurations. Now, there are a few things that we need to know. First of all, we need to be able to draw an arrangement, something like this. Now, the way I've drawn it here is I have the lower energy at the bottom and the higher energy toward the top. That's just because it's a typical convention to do so, to have lower energy toward the bottom. You could, of course, start with the 1s at the top and work your way down as well. Secondly, another thing that you have to know is the maximum number of electrons per subshell. So you need to know that S holds 2, P 6, D holds 10, up to 10, and F holds up to 14 electrons. You can't go above those numbers, okay? And finally, the last thing you need to know is that the order goes with a diagonal arrow up and to the left. So it goes in this way, and then when we go 2s, then we go back to 2p, 3s, and then back to 3p, 4s, and then back to 3d, 4p, 5s, and you continue on in this way. All right. So let's put this to the test. We're going to do aluminum first. So aluminum, I look on the periodic table, and it has 13 protons, which means that it has 13 electrons since it's neutral. So I'm going to keep going until I get to 13. So I do 1s2, 2s2, 2p6. Let's see, how many is that so far? 10. I got to keep going. So I'm going in this way. So after 2p is 3s. So 3s2. Okay, I'm not there yet, so I got to, pardon me, keep on going to 3p. 3p, and it looks like to add to 13, I need one more. There we go. So I'm going to double check. Yes, those exponents, and what I'm adding are these exponents, these numbers up at the top there, to make sure that they add to 13. So I have 2 plus 2 plus 6 plus 2 plus 1 equals 13. Great. That's good. All right. So that is aluminum, the electronic configuration for aluminum using the triangle method. There you go. 1s2, 2s2, 2p6, 3s2, 3p1. All right, now let's do another one. Let's do bromine. All right. So bromine, I look at the periodic table, and it's got 35 electrons. So 35 protons. It's neutral, so it also has 35 electrons. All right, so I'm going to go with these arrows again until I get to 35. So 1s2, 2s2, 2p6, 3s2, 3p6. I don't think I'm there yet. Nope, that's only 18. Then, let's see, after 3p is 4s, 4s2, great, 3d10, great, and then 4p, how many do I have so far? Let's see, that's 10, 20, 30. I need 5 more, so 4p5. Now I add those exponents again, that 10, the 5, the 2, all of those, and yes, indeed, I get to 35 as my sum. Great. So that is for bromine. Now I can also use the shorthand notation. So I'll use the noble gas that's one row up from bromine. That'll be argon. Argon has 18, so I take out the first 18 and write the rest as the remaining. And in this way I can identify my core versus my valence electrons for any atom. And there you go, the electronic configurations using the triangle method. If I wanted to do it for ions, then I would adjust the number of electrons. Negative ions, I need to add electrons. A positive ion, I would subtract electrons. Thank you, and hope you'll check out our other videos as well.